going to treat a new topic under differentiation, which is called product of differentiation. When we talk of product, what comes into mind is multiplication of two functions. Good. Then here, let's do a little bit recap of what we learned in our last video, Introduction to Differentiation, before we come to product of differentiation. In Introduction to Differentiation, we learned first order of differentiation, how to differentiate. You see, we learned that if you have a function in this form, axn, if you want to differentiate axn, the exponent or multiply the coefficient of the x, then you reduce the exponent by 1. Good. When you want to differentiate sine ax under differentiation, differentiation of sine will give us cos ax. If we are differentiating cos ax, it's minus sine ax. Differentiating y exponent ax, exponential, that one you get a, the coefficient here of x, multiply y exponent ax, the same function. But if you are differentiating then ax, you get 1 over x. Why? You first differentiate what is here. If you differentiate this, you are going to get only a over the same function. So a will cancel a. So you get 1 over what? X. Let's get back to our topic for today. Product of differentiation. Product of differentiation. Under product of differentiation, let's look. If y is equal to vu, where v and u are a function of x, then we can say dy dx, when we are going to differentiate y with respect to what? X, u is u dv over dx plus v du over dx. Now, this u and v are in this form. You get it in this form, in a bracket form. Okay, so v is one function on its own, u is another function on its own. So let's take some multiple examples for us to understand this topic. Let's take an example number 1. Example 1. Says, let's say, find the differentiation of the following functions. Okay, so let's say a, you have a, y is equal to 3x squared sine 2x. 3x squared sine 2x. So you're going to look at how you will solve this. Now, looking at this example, we have 3x squared sine 2x. So in this form, what you can see over here, you can see is two functions multiplying themselves. So this function is 1, another function is this. Good. Now we can make this being u, v, and this is out u. So you say let v equal to 3x squared and u equal to sine 2x. Good. Now, from here, we know dy dx is equal to u dv over what? Dx plus v du So here, you just make substitution into the formula. Our u is sine 2x d over dx. What's your v? 3a squared. Okay? Plus your v, 3a squared d over ds u. Our u is sine 2x. Now, this means that we are going to keep one constant, we differentiate the other. We keep this constant, we differentiate the next. Okay? So, continuing from there, we can say that now from here, keeping this constant, sine 2x, let's differentiate this. This is in the form of that. Our exponent is 2 and our coefficient is 3. Okay, so this time that 6. Reduce the exponent by 1. This, so it's left with that. Plus, let's keep 3x squared constant. We differentiate sine 2x. Sine 2x. Differentiating sine give us cost. So our a is what? 2. Okay, so a cos ax. So it will be 2 cos what? 2x. Now let's expand the bracket. We are going to get 6 sine 2x, okay, plus 6 x squared cos 2x. Now, we see some similarities between these two. So we can do some factorization over here. So factorize 6x out. We are going to get, this will be left with sine 2x plus x cos 2x. This will be our final answer for example number 1. Let's take another example. Example 2. Example 2. Let's say y is equal to 3x into a square root ln of what? 2x. Now looking at these two, we can see it's a product of two functions, another function. Okay, so you say let u be equal to 3 root of what? X. Okay, then v be equal to ln what? 2x. Good. Now putting it into the formula, dy dx will be equal to u 3 root of what? X d over dx v ln 2x plus v ln 2x d over dx 3 root of what? X. Now we're going to do our differentiation. To differentiate that, we keep one constant, we differentiate the other. Keep the other constant, we differentiate the next. So if you keep this one constant, you have 3x in a bracket ln 2x in this form, which means you differentiate that. If you differentiate ln 2x, which means f prime of what? X over f of what? X. Which means if you differentiate ln 2x, if you differentiate this, you are going to get 2 divided by the same function, 2x. This will cancel that, giving us 1 over x. So ln 2x will give us 1 over what? X. Plus ln 2x. Now, for this one, 3 root of what? X can also be written as 3x exponent half. Okay, so if we differentiate this time that will give us 3 over what? 2. X exponent negative what? Half. Because minus 1 give us x exponent negative half. So putting it here, we have 3 over 2 x exponent negative what? Half. So let's expand our bracket and see what we will get. This time that. Now, this also can be written as 3x exponent half times this divided by x. Good. Plus ln of 2x times that. So you're going to have 3 over what? 2. We have our x exponent of negative half. Okay. Indices form. If you remember from indices, assume you have a exponent n over a exponent n. In indices form, a is equal to n minus what? N. Okay. So from that, we can change this into a simple form. Simplest form, we will say 3x exponent what? Negative half. Because the exponent of x here is 1. So minus that will give us negative half. Plus 3 over 2 ln of what? 2x x exponent negative what? Half. So you can factorize here because you can see some similarities what? Over there. We have 3x exponent negative half out. Here will be left with what? 1. Plus, here will be left with half. Then what? 2x. Okay? But this also can be written in a proper form. 3 over what? Square root of what? X. Okay? Then we get 1 plus 1 over 2. Then 2x. Very simple. Very simple. This will be your final answer for example 2. Let's try another example. Example 3. For example 3, let's say y is equal to e exponent 3x sine 4t. Okay, e exponent 3t sine 4t. Now from here you see, let u be equal to what? E exponent what? 3t, v2 be what? Sine what? 4t. Okay. Following that, we can say dy over dx will be equal to the u, e exponent 3t, v over what? Dx sine what? 4t plus your v again sine what? 4t, v over what? Ds, we differentiate what? E exponent what? 3t. Okay, now we are differentiate y with respect to t. So this one will change to t form, okay, into t, because it's y with respect to what? T. Now you keep this constant, we differentiate this. You have 3 et. If you want to differentiate this, sine ax, now it's in terms of t, so cos. So we have 4 cos what? 4t plus, keep sine 4t constant, differentiate the next, e exponent ax, now e exponent 3t, s in terms of t, so you can see that, say 3 e exponent what? 3t. So we have to expand the brackets now. Expanding this bracket will give us 4 e exponent 3t cos 4t, and expanding this bracket will give us 3 e exponent 3t sine 4t. Can we see any similarities over here? Yes, because we have e exponent 3t exponential e exponent 3t. So we factor that out. E exponent 3t out. What will be left here? 4 cos what? 4t plus, this one to be left 3 sine 4t. This will be our final answer for this example. Choosing our last example, example 4, let's look at how it will be. Example 4, having y is equal to e exponent 4 theta, okay, then ln of what? 3 theta. Good. So let u be equal to e exponent 4 theta, then your v will be equal to ln what? 3 what? Theta. Okay, now let's put it into the formula. Our dy dx will be equal to, our u is e exponent 4 theta, differentiate with respect to what? Theta. You see, you're differentiating y with respect to theta. Okay, so the v will be what? That plus b over e exponent what? 4 theta. Okay, now we must do our differentiation now. We keep this constant, we differentiate the next. We keep this constant, we differentiate the other. So e exponent 4 theta. What is the differentiation of this? As I thought, you differentiate what is in the bracket. Okay, you get 3 over the same function. So you're going to get 1 over theta plus, this is constant. We differentiate what is in the bracket. E exponent 4 theta, e exponent ax. So we have 4 e exponent what? 4 theta. Good. Now let's expand the bracket. We have e exponent 4 theta all over what? Theta plus, when we come here, we have 4 e exponent 4 theta plane. Okay, now can we do some factorization over here? Yes. When you factorize e exponent 4 theta, e exponent 4 theta out, here will be left with 1 over theta plus, here will be left with 4. Okay, are you following? 4 ln 30 3 what? Theta. that will be the final answer for this. So you see, product of differentiation is very simple. The only thing you have to know is your formula, which means the y dx must be equal to u dv dx plus v du dx. And what you have to know is you have to identify your u, you identify your v. Then the next thing is very simple. Substitute your formula, your u and v into the formula. You keep one constant, you differentiate the other, plus you keep the other constant, you differentiate the next. That's all about product of what? Differentiation. If you found this video very useful to you, please like the video and subscribe. Press the subscribe button for us. And aside that, you can try and share with your friends for them to also understand this topic. Those who are having challenges with this topic. And also meet you next Tuesday for the next topic under quotient of differentiation. Thank you.